Transformations is the way of making all types of different functions from just using your parent functions. So the parent functions are something you definitely want to memorize. Y equals x squared, y equals 1 over x, y equals x cubed, square root of x, for example. These basic shapes, you want to know what they look like. But transformations lets you form all the other types of functions from those. So what we're going to talk about first is the types of transformations. So we have shifts. We can shift graphs to left and right. We can shift them up and down. We can stretch them out in a horizontal fashion, or we can stretch them out in a vertical fashion. So let's think about all of these real quick. So a horizontal shift. So first of all, when you're dealing with horizontal shifts or horizontal compressions, anything in the horizontal dimension, which is the x on your Cartesian coordinates, you're going to be affecting the interior of the function, where the x is. So let's say we had our function f of x. If we instead replace x with x minus some constant a, what that tells us is we're shifting by a to the right. So, if a is negative, meaning we would have we're adding something, that's shifting to the left. So this is to the right, this is to the left. So, that's, for example, if you just had this function, x minus 2 squared. You should be able to tell that, oh, that is my regular function x squared, except instead of an x, I have an x minus 2. So that's my regular x squared parabola shifted to the right by 2. A vertical shift is when you, now vertical is in the y dimension of your Cartesian coordinates, up and down. You're going to subtract or add something outside of the function. So, if f of x you change to be f of x plus a outside of your function, that's a shift up. F of x minus a is a shift down. So, for another example, if you had the function x squared minus 1, that is your standard x squared parabola, moved down 1 unit. Okay, the other types are the compressions and stretches. So let's look at a horizontal stretch. So a horizontal stretch is when you multiply by some factor inside the function. So if you have f of x, and you change that to f of ax. So you're multiplying something inside. What that does is that reduces the function by a factor of a. So let's think about what that might mean. What we're saying is the function is getting narrower horizontally by a factor of a. So if you had something like 2x squared, that's your standard x squared function, but now it's twice as narrow. So it's going to get skinnier by exactly double. So that's what a horizontal stretch is. So you can see if a is 1, it doesn't do anything. But if a is 2 like this, it gets narrower. Let's say instead we had 1/4 x squared. We're getting narrower by a factor of 1/4, which is actually getting wider then by a factor of 4. So if your number a is less than 1, it's a fraction, your function gets wider. If it's bigger than 1, your function gets narrower. And we're all talking about in a horizontal dimension for this. So finally we have vertical stretches. Now keep in mind too, for most functions, horizontal and vertical stretches are kind of interchangeable because you can kind of think of it as one or the other. For example, if you actually factored this out, you would get 4x squared. And that's what's going to happen here. Because on a vertical stretch, as you might have guessed so far, you put that constant outside the function. So you can see this kind of looks like what would happen here. So putting a 2 on the inside is actually the same as putting a 4 on the outside. So horizontal and vertical are kind of interchangeable, and that'll happen a lot. So you can think about it in whichever way you prefer. But a vertical stretch in general is something gets that much stretched out vertically. And this one is not in reverse. So a 4x squared means the function got 4 times as stretched out in a vertical dimension. The other way you can think about that is all of your y coordinates on your graph just got multiplied by 4. So let's think about what that would mean for like our x squared function here, like this. We would take our standard x squared graph. I'm just going to do the first couple of points. Now, our vertex is 0, 0. If you multiply the y coordinate of 0 by 4, you still get 0, so the vertex didn't change. This is y equals x squared. The first point on here would be when x is 1, y is 1. Plug in 1 for x. You can see on this one, though, we're going to multiply that by 4. So instead of 1, 1, we would get 1, 4. And then the next point. When you plug in on your regular graph, if you plug in 2, 2 squared is 4, you would get 4. However, on this graph, you're going to multiply that 4, you're going to get 16. So every y coordinate got multiplied by 4 and is 4 higher now. That's the way you can think about graphing it. Conversely, if you had something like 1/2 x squared, that means every y coordinate is now half of what it used to be, so the graph will get lower, and in this case, that also means wider, like if you had a horizontal stretch. So vertical shifts, horizontal stretches, and vertical stretches are the 4 types of transformations that you're going to